over pure substances and mixtures, and then we're going to break down the two different types of mixtures, homologous and heterogeneous mixtures. Okay, so to begin, a pure substance, it can be either an element or a compound, so it can be qualified as both. So if it is qualified to qualify as an element, it cannot be broken down any further, whether that's physically broken down or chemically broken down. Okay, so the smallest particle of an element is an atom. So these atoms, they can form molecules, but in order to be still considered part of the element, it would have to be atoms of the same element. Okay, so for example, like oxygen in the air that we breathe, O2, that is a molecule that there are two oxygen atoms that are bound together. It's still elemental because it's still the same type of element. Okay, and then for compound, it can be broken down by a chemical process. So the smallest particle, instead of an atom in this case, is going to be a molecule. So it's going to be made up of two or more different types of atoms. Okay, so CO2 has carbon and oxygen. This would be a compound. Okay, or like water, H2O, hydrogen, oxygen. It makes up a molecule. It's considered a compound as well. Mixtures are going to be made up of two or more pure substances. Okay, so it can be separated into the pure substances using physical processes. And we're going to be going through separating out mixtures here a little bit later. But for the example here where it shows tap water, you can see that there's different types of molecules compared to the pure distilled water where they all have one type of molecule. This would be a compound or pure substance, okay, where we have the water, H2O, hydrogen, oxygen, okay, and then this mixture, we're going to have a lot of different things, such as water. There can be like fluoride added to tap water. There might be rust particles depending on your pipes and things like that. Okay, so moving on to mixtures, and we're gonna kind of skip a few of these pages to get to mixtures. So I believe it is page 7. So we have homogeneous and heterogeneous mixtures. Okay, so starting with homogeneous, whenever you see one of these mixtures, they're gonna be visibly indistinguishable parts. Okay, so when you're looking at it, it might look like one whole. And so the example of this is solutions, okay? So for a solution, there's a solvent and a solute. So the solvent is the larger portion. So if you were thinking about like salt water, it would be the water, okay? And the solute is going to be the smaller proportion, which is salt in the case of salt water, okay? So for salt water, it's going to be a solid mixed in a liquid. Okay, we can have solids and solids mixed together and have a homogeneous mixture, such as steel or any other type of metal alloy. Okay, this is where they're taking two solid elements and blending them together. And so it's going to be a solid mixed in solid. And then if we think about like the atmospheric air, it's going to be gases mixed in gases. So whenever you look, it appears that the air is all uniform, and it does have the different molecules such as nitrogen, CO2, oxygen, all throughout. Okay, getting into heterogeneous mixtures, these parts are visibly distinguishable, so you're going to be able to see the different parts in the mixture. And if allowed to settle or sit, it will settle out. Some of the particles will settle out. Okay, and so an example of these are suspensions. Okay, so one example, which is not on here, would be something such as water and oil, okay, both liquids. If you were to shake a bottle of that, you would be able to see the little particles of the oil mixed with the water, okay, and if you allow it to set, it will settle out. Okay, sand is an example of a solid mixed in a solid where you can see the different parts. So you might see like little black specks, you might see shells, and then just the fine-grained sand. The dust in the air, so you can see the particles of the dust mixed in with the gas of the air. Okay, and then you might have had liquid that you've had to shake before, or a medication that you've had to shake before, and the reason for that is because there are solids in it that when left to sit, it will settle out. So that would be an example of a solid in a liquid. Just lastly, colloids. These are mixtures in which large molecules or particles of one substance are dispersed through a second. Okay, so things like blood, milk, and shaving cream. So things like blood, there are large particles that are kind of bigger proportions to the liquid part of our blood. Okay, and then with milk, they add in different agents in order to help keep the milk from separating out. So these are colloids. So those larger particles that generally would settle out, they're suspended throughout the solution. So in milk, they use an emulsifier in order to accomplish that.